And then next week, we have a quiz on, let's see, so we were supposed to have a quiz on Saturday, but we didn't have the class on Saturday, so we'll have it today on the finance. And then we have another quiz, which was supposed to be today. Here, it's supposed to be November 8th, but this will be next week. Okay, so it's a big assignment. It's on the Khan Academy on limits and continuity. So I'm going to just go through some of the concepts quickly today, but not all of them. But you will have the quiz based on all of them in the Khan Academy section on limits and continuity. So just to show you. Oh, I didn't know they had Japanese Khan Academy. Okay. Log in. No, we don't need to log in. Just go here. And subjects. And calculus. So this is the first Khan Academy subject where we looked in the calculus section. And here it is, limits and continuity. But there's more here than we're actually going to cover. So he covers limits, tables, graphs, one-sided, all this stuff. Okay, kind of a lot, more than we need. So I told you here, no trigonometry, so that means well, anyway, there's some stuff that uses trigonometry, like sines and cosines. You don't need to know any of that. And formal definition, epsilon delta, you don't need that either. So that's here, formal definition. You don't need that section. Intermediate value will not be included. So here's the intermediate value, so you don't need that. Limits from equations, factoring and rationalization will not be included. So that's limits from equations, sorry, this one, not this one, but this one, will not be included. And squeeze theorem is not included, and removable discontinuities are not included. So squeeze theorem, here, limits of trigonometric functions, nope. And removable discontinuities, no. Okay? So it's actually a big assignment. I'm not sure how many hours of video are in here, but it takes some time to go through it. I'm not going to go through all of the material here in class, and but I thought this is another way for you to get it. Okay, so the homework will be based on what's in here, not based on what's your homework in WebAssign. Okay, that's different. I'm sorry, the quiz will be based on what's in here. The quiz will be based on what's in here. Quiz next week. Okay, anybody have any questions about that? Okay, so you have to do Khan Academy. All right, anybody have any questions? Okay. All right, so we have to do a little of it ourselves, although he does a good enough job without it, but it's worthwhile. So let me extract the PowerPoints that you guys have the same access to these PowerPoints. And chapter 10, and this is of course from chapter 10 in the book. And let's just go through some basics here. Okay. So, as I said last time, we have to study limits just in the same way that sometimes you need to figure out how a microscope works, even though you're actually not interested in how a microscope works. So in the same way, we're not really interested in limits, we're interested in rates of change, and limits are used, just like a microscope is used to study biology. Okay? So rates of change are calculated by derivatives, but an important part of the definition of a derivative is something called a limit. So we need limits. Okay, so this kind of is an introduction to the concept of limit. So you should have seen in your homework many times where they presented you with a table somewhat like this to define a function. So the function here is what? What is the function that's being defined here? So you don't really need all of this because we've actually given the formula for it, but what is the function here? 2 plus x, but usually they don't tell you this part, they just give you the table as the definition. So here, the table should actually match this. They're giving us 2 parts that define the same thing, so they should match. So for example, if I put 2.9 for x into this function, what do I get out? 2.9 plus 2 is 4.9, right? So that's why this is 4.9, right? If I put 2.99 for x into this, what do I get? 2 plus 2.99 is 4.99. Okay, so when I put in 2.9, I get this. When I put in 2.99, I get this. When I put in 2.99, I get this. When I put in 3.01, 3.01, 3.01, 3.1, I get these numbers. Right? Okay, so you should have seen that before. This table defines the function, so to speak. This also defines the function, but kind of ignoring this part for now. Okay, now, what do we mean by this word limit? Well, we could ask a question like, what's the value of this function at 3? Now, what do I mean by that? When I use that language, the value of the function, what does that mean? So the value of the function at 2.9 is what? 4.9. So it's the output. The value means the output, or the y value, or the height. Right? Those are all the same thing, right? So now I'll ask you, what's the value of the function at 3? That means what? What's the output of the function at 3, right? Or the y value, or the height. Okay, so suppose we ask that question. Now, if we didn't have this formula, then you don't know the answer, right? Right? That's the idea. If we didn't have the formula here, you wouldn't know the answer. Okay? But the idea of a limit is, what would you guess the answer should be? Now, how can you guess what the answer should be? That's kind of not a very clear question. How do you guess what the answer should be? What I mean by that, though, is if you looked at values close to 3, is there a pattern that would lead you to make a certain guess at 3? And if there is a pattern, and if you can make a certain guess at 3, you would say that's probably what the limit is at 3. So that's what we mean by limit. So we don't know the formula, and we're trying to figure out what the value is at a particular value. I'm sorry, yeah, I hate that language. We're trying to figure out what the output is at a particular input. And we do it by kind of looking very close to that input and then making a guess. Then if we get the guess, we would basically call that the limit. We'd say the limit at 3 is blah, blah, blah. Okay? So if we do that here at 3, now we don't know what this is. This is not available to us. This is hidden. Okay? So what do? We look at values that are close to 3. What does close to 3 mean? Well, 3.1 is kind of close to 3. And 3.01 is even closer to 3. And this is even closer, and this is even closer. So why not look at these values? And then we can do the same thing for numbers that are less than 3. So 2.9 is close to 3. 2.99 is even closer. This is closer. This is closer. So what do? We look at these numbers. So what do we get? 4.9 4.99, 4.999. This one, what do we get here? 5.1, 5.01, 5.01, 5.001. So if you look at this pattern here and here, what would you guess this should be? So if you look at it, doesn't take a huge amount of intelligence to make a guess. Well, I'm not sure the guess is going to be right or not, but I think everybody would guess the same thing, and that is 5. So we'd probably say the limit is 5. Okay? So that's the language that you should learn to use. So the language is, first of all, how did I just say that? I said the limit is 5, right? So how do I even write it a little more clearly? So I'd write the limit, first of all, I'd write the limit is 5, but that doesn't really state the whole problem. So let's say it a little more clearly. Limit of what? Limit of this function, right? Right, so let's give that function a name, let's call it f. Okay, so I'll say the limit of f is 5. But that's not quite right either, because where? It's not when x equals 10. I'm not guessing that the limit is 5 when x equals 10. I'm guessing that the limit is 5 when what? When x equals what? 3, right? So if we want to state it all clearly, we should say the limit of f when x is close to what? To 5. No, sorry, close to 3 is 5. Okay? So that's being more clear. I mean, you just, be sloppy, you just say the limit is 5. But the limit of what? The limit of f is 5. Where, though? Not just everywhere, but specifically when x is what? Near 3, the limit is 5. Okay? So now, maybe we even want to write the function, even though we're not supposed to actually know it, but in many cases we do know the function. So we would write the limit of this specific function. What is the specific function? 2 plus x, right? 2 plus x, and then when x is close to 3 is 5. Okay, so we can go that far. And then if you want to get a little bit more formulaic about it, you can write it like this. The limit 2 plus x, that was the function, is, usually we'll write that as equals 5, right? And then we have to say where. So where? When x is close to 3, that is written like this. X is close to 3 is written like that. X approaches 3. Okay, and now you could put that x approaches 3 over here, you could put it here, you can put it anywhere, but usually they put it here. Okay, so that is just a way of writing this. So the limit of 2x plus x, 2 plus x when x is close to 3 is 5. You can write that in shorthand like this. The limit of 2 plus x as x approaches 3 is 5. Okay? And then if you want a little bit more shorthand, you can just finally write it like this. If I do that one more time. Okay? So the function goes here. X gets closer to goes there. And the answer goes there. So this is the y value, or the height, that we're guessing. This is the function, and this is what x is getting close to. Okay? All right? So in general, we would write it like this. The limit as x goes to, well, I'll start out like that, of some function is some number. So instead of writing a particular number, I'll write L. So L just stands for, is L the x value or the y value? The y value, right? It's the output. Okay, so L is the output, and instead of writing 3, let's be just one more step in terms of general. X approaches some A, not just 3, but something. So that's the general expression, general way to write it. So then if you want to talk about a specific function, like this one, you'll put that in here. If you want to talk about at a specific place, instead of A, you'll put that here. And if you know the answer, you'll put that here. Okay? So this is the, and then if you don't want to have to, you know, when you're typing, it's really hard to write this little part underneath, right? So you can also write it like this. The limit, I think they write f of x as x arrow 3 equals L. I think that's how they might write it. So then you don't have to write a subscript or something underneath, which is easier to type. Okay, but it means the same thing as this. All right? So, how about if the function we just looked at was this one here, right? But suppose the function was a different one. Suppose it was f of x equals 2x. Okay? And suppose I wanted to know the limit of this one as x gets close to 5. Okay, so what do we do to try and figure this out? We would make like this table, right? I mean, you don't really need to do this probably, but this is how we were going to do it in the most basic way, step by step. We would do what? We'd say we want 5 here, and we don't know that, right? So what do we look at? The idea that we used at the beginning was to do what? To look at values close to 5. So what does close to 5 mean? Well, maybe 5.1, 5.01, 5.001, and then on the other side, we might look at 4.9, 4.99, 4.999, right? Like that. Now, we happen to know the function, so we don't need somebody to tell us what to put in here. So at 4.9, it's what? It's 9.8, right? And at 4.99, what is that? 9.98, is that right? Because this is 1/100th away. So doubling it is going to be 200ths away, right? Okay? Is that right? Yeah, I think so. And this is going to be 9.998, I think. And then over here, it's going to be what? 10.2, 10.02, 10.002, right? Something like that. And then our job is to try and estimate what this is going to be. Well, it's obvious what it's going to be. Anyway, if you look at the pattern here and the pattern here, it's what? We're going to estimate that it's 10. So we would write, this is 10, right? Okay? So that's the notation, and that's the language. Okay? The notation and the language. Okay? Now, what if we're not given the function in this format? There are other ways to indicate what a function is. For example, a graph can also tell you what a function is or how it behaves, as well as, of course,